today. It's bright and sunny outside here. I hope the weather at your place is great too. For those of you who do not know me, I'm Dr. Nandi and I frequently go live on YouTube on my channel and lecture on math topics or solve math problems. In my channel, I have solved all kinds of math problems, including statistics, algebra. When you get a chance, please take a look at my channel. Please take a look at my videos. If you like my videos, please give me a thumbs up. That really motivates me. And also, please subscribe to my channel by hitting the red subscribe button. Without further ado, let's get started on today's problem. This is a problem on normal distribution, which is a bell-shaped probability distribution. For a statistics class with 40 students, the average score is 75 with a standard deviation of 5. Assuming that assume that the test scores are normally distributed. A student's test is selected at random. A. What is the probability that her score is between 76 and 80? So first we will draw the diagram, bell-shaped diagram. Okay, these are the test scores on the horizontal axis. That's your random variable, test scores. And you have, of course, relative frequency on the vertical axis. Relative frequency is same as probability. And this is a relative frequency or probability. And you have a bell-shaped distribution. This is your bell. There is only one point on the horizontal axis where the relative frequency is maximum, and that's where the mean is located on the horizontal axis. Okay, so this is the point. Relative frequency is highest. It's bell-shaped, means the left half is equal to the right half. The mean is given as 75 and sigma is given as 5. We have been asked to find out what is the probability that a score is between 76 and 80. Look at the number 76, that is greater than 75. Since it is greater on the number line, it will be slightly to the right of 75. So this is we draw a vertical line to meet the bell-shaped relative frequency distribution curve or histogram, and this point is 76. And the upper limit is 80, which is also located further away from the mean on the right. So you draw another vertical line at 80 to meet the bell-shaped probability histogram. And this is the area. So probability that the score is between 76 and 80. X is your test score. Okay, so this is a bell-shaped diagram. Okay, so the area is the area under the normal distribution between 76 and 80. Okay. So I have to find the area, the shaded area under the bell-shaped curve between 76 and 80. Between 76, this boundary is 76, this is 80. We draw two vertical lines to meet the probability histogram. Find the area under the curve. I will be using TI-84 calculator. I suggest that you use TI-84 because it is relatively easy to find the area under the normal curve using TI-84. So how do you do that? You press the second key, then you press the verse key, which is in the third row, and then you scroll down with the down arrow key to normal CDF, normal cumulative distribution function. So let me show you how I'm going to do it. So put the calculator on, press the second key, and then the verse key in the third row, second and verse. Then I'm going to scroll down to normal CDF. which is number 2, and hit enter. Okay, so first thing the calculator will ask me is lower. This is the lower boundary. I am starting my calculation from 76. So I plug in, type in 76. Upper, I type in 80. Okay, this is lower, this is upper. Okay, then it's asking for the mean. The mean is 75. Okay, then you go down to paste and hit enter twice. Paste and hit enter twice. Whenever you are on paste, you have to hit enter twice. So probability between 76, x is the test code, between 76 and 80 is equal to, so I'm on paste, I'm hitting enter. I'm hitting enter once and then I'm hitting enter twice to get the answer, which is 0.262. What does it mean? There is a 26.2% chance that the test score is between 76 and 80. Okay, so that's how you find what is the probability for the test score to be between 76 and 80. So that was part A. Part B, probability of x greater than, above 80, x greater than 80. Greater than 80, I will use a different color, is area under the curve to the right of 80. So let me write with red pen, so that x is greater than 80. Okay, so this is the area I'm interested in. So in this case, I will use again, I will use second button, then verse button. However, and then scroll down to number 2, which is normal CDF. Normal CDF. Always use normal CDF. My lower is the left boundary. Now it is 80. So what is my upper? My upper is always a large number on the right, very large number on the right. It is 1 followed by 99 zeros, and the way we do it in this calculator, 1, okay, we type 1 for the upper boundary, then we press the second key and then comma. That will bring you the small cap E. What is E? E is exponent. Basically, 1 E99 tells me 1 followed by 99 zeros, which is a very large number on the right. So the curve stretches to infinity on the right. The remaining things do not change. Mu is still 75 and sigma is still 5. So P greater than 80, x greater than 80 is equal to, so I do second verse, then 2, okay, so here I go. My lower boundary is now 80. Okay, my upper boundary, first I type 1, then second button, and then comma button. Comma button is on top of 7 to get the E. E stands for exponent or 10 to the power of, and then I type 99. That means 1 followed by 99 zeros, which is a large number on the right, is suggest an infinite number. Okay, mu and sigma do not change. I go down to paste and hit enter twice. And the answer is 0.1586. Notice I'm doing it at least up to 3 or 4 places of decimal. Okay. So that is x greater than 80. Part C says what is the probability that a score is below 60. Okay, below 60. Now 75 is in the center, numbers increase on the right from the mean, numbers decrease from 75 on the left, and 60 is less than 75. So 60 is somewhere over here on the horizontal axis. Okay, this is your 60. And I am interested in x less than 60. That means I want this area. So my upper boundary in this case is 60. What about my lower boundary? Lower boundary is a very large negative number on the right, and it will be minus next to the enter, then 1, then second comma will give me the small cap e, and 99. So the way I will do it is probability of x less than 60. Again I do second verse, that is number 2, which is normal CDF. Always use CDF, never use normal PDF. My lower is, remember the curve stretches to negative infinity on the left. I put the minus, this is the minus sign next to the enter, not the minus on top of plus. Minus, then type 1, then type second, then comma, which is on top of 7, that gives me the capital E, 99. That means minus 1 followed by 99 zeros. Very small negative number on the left. Okay. Upper, you're stopping at 60. And mu and sigma still remains the same, 75, and sigma is 5. And then I go on paste and hit enter twice. So let me show it to you how to do it. So second button, then verse button. Number 2. My lower is a very small negative number on the left. So first the minus next to the enter, not the minus on top of plus. Minus, then 1 button, then second button, and comma button on top of 7 will give me the E. E stands for 10 to the power of. E, then I type 99. What does it mean? Minus 1 followed by 99 zeros, which is a very small negative number on the left. Curve stretches to negative infinity on the left. And the upper, I want below 60, so my upper is 60. Mean and standard deviation do not change. I go to paste and hit enter and enter. And the answer is Px less than 60 is a very small number. 0.0013. 1 in 1,000 chance that somebody will get less than 60. Okay. Part D says what is the minimum score for the top 10%? Minimum score for the top 10%. So this is the curve. Mu is here, 75. Sigma is 5. Top, whenever they talk about top, that means on the right. That means this is the unknown score we want to find out, such that the area on top of it is 10% or 0.1. Okay, that is the area to the right of the x. That gives the top 10%. This is the minimum score to be on the top 10%, such that the area under the curve to the right is 10%. So what about the area on the left? It is total area under the curve is 1 minus 0.1 is 0.9. So we have to work with the area to the left of boundary of x, to the left of x. On the right of x is 10%, top 10%, but the calculator, we will work with the area to the left of x, which is 1 minus the top 10%, 1 minus 0.1 or 0.9. Also, we cannot use second verse 2. So in this case, we will use to find x for the top 10%. Okay. What we will do is, we will press the second key, then the verse key, then we go down to number 3, which is in norm. Remember, when we know the area to the left of the unknown x, we have to use number 3, which is in norm. And the first thing it asks is area. It's always looking for area to the left of the unknown. Area is 0.9. Mean is 75. Sigma is 5. Okay, and then we go to paste, enter and enter. So, let me show it to you. What am I doing? Second verse. Okay, second verse. Go down to number 3. Not number 2 anymore, number 3. It is asking for area. Area is 0.9 to the left of the unknown x. Mean is 75. Standard deviation sigma is 5. Paste, enter and enter. And the answer is 81.4. So this x is 81.4. So x is 81.4. That is your answer. 81.4. So anybody who scores above 81.4 is in the top 10%. Okay? That's for the top 10%. Now they want for the bottom 10%. So the picture is slightly different. Now bottom means we are on the left. So this is mu 75, sigma is 5. Bottom 10% means we want to find this x as that the area to the left of it is 0.1. Bottom 10%. Same second. So if this is x is 81.4. Let's call this one as y or something like that. Bottom 10%. So to find y, the bottom 10%, the only thing that will change is in norm, area, in norm, second verse 3, area to the left is now area is no longer 0.9, area is 0.1, mu is 75 and sigma is 5. Okay, so second, so you understand, always area to the left. Now the area to the left of the unknown y, to find y, let's call this y, to find the unknown y. Area to the left will be 0.1. So second verse 3, area is 0.1. Nothing else changes. Mu is 75, sigma is 5. Then go to paste and hit enter twice. And the answer is 68.59. So this is 68.59. Or you might simplify to 68.6. So y is equal to 68.6. So anybody who scores below 68.6 is in the bottom 10%. And then they talk about the middle 50%. So that was E. Let me do F over here. Let me try to use a different color paint so that there is no confusion. Okay, middle 50%. Okay, middle 50%. That means the area in the center is 0.5. Now this is part F. So we want to find x1 and x2. Okay. Now if the area in the center is 0.5, area in the two tails, okay, these are called the tails. Okay, these areas are the tails. 1 minus 0.5. So area in tails is 1 minus 0.5, which is also 0.5. Now bell-shaped diagram is symmetric, so area in each tail is half of 0.5. Area in each tail is 0.5 divided by 2, which is 0.25. So this area is 0.25, this area is 0.25. Now to find x2, use area as 0.25 in second verse 3. So to find x2, area in the left tail is 0.25. So we are going to use the same second verse 3. So second verse and 3. Area in the left tail is 0.25. Nothing else changes. Paste, enter and enter twice. Oops, what happened? Second verse 3. Area in the left tail is 0.25, mean is 75. Paste, enter and enter. And the answer is 71.62. So this is important. Use area is 0.25 for x2. Okay. So that is 71.62. For x1, area to the left, use area is 0.5 plus 0.25. 0.5 coming from the center and then 0.25 in the left tail is 0.75. Okay, so again use second verse 3, only change because you have 0.25 in the left tail plus 0.5 in the center. 0.5 plus 0.25 is 0.75. That's the only thing that will change. And paste, enter and enter. And that number is 78.4, you might say. So let me write it clearly, is equal to 78.4. So what does it mean? It means that middle 50% will be between 71.6 and 78.4. Let me walk through the problem again. For a statistics class with 40 students, the average score is 75 with a standard deviation of 5. Assume that the test scores are normally distributed. A student's test is selected at random. What is the probability that a score is between 76 and 80? Bell-shaped diagram for the test score probability distribution. Mean is the point where the relative frequency is the highest or the height is highest. That is 75, standard deviation is 5. 76 is a number greater than 75 on the right of 75. 76 and 80. So use second verse number 2, normal CDF. My lower boundary is 76, my upper is 80, my mean is 75, standard deviation is 5. Go down on paste, enter twice. I'm using TI-84. And that probability is 0.262. What does it mean? There is a 26.2% chance that the student's test score will be between 76 and 80. Greater than 25%. Okay? What is the probability, part B, that a score is above 80? Above 80 means on the right of 80. So in this case, the lower boundary is 80. And what about the upper boundary? Always the normal curve stretches to infinity on the right, positive infinity on the right. So the lower is 80, upper is 1, type 1. Then second button, comma button gives you the E. E stands for exponent or 10 to the power of. After that E, you type 99. That means 1 followed by 99 zeros, a very large number on the right. Okay. And mean and standard deviation remain the same, so probability of x greater than 18 is about 15% or 16%. Next was probability less than 60. Less than 60 means on the left of 60. So here your upper boundary is 60, the lower boundary is a very small negative number on the left. Notice I'm not saying very large, it's a very small negative number. So it will be negative minus next to enter, not the minus on top of the plus. Minus, then 1, then second comma will give you the capital E, which stands for exponent or 10 to the power of, type 99 after that. Means minus 1 followed by 99 zeros. Very small negative number on the left, negative infinity. That's your lower boundary. Your upper is 60, mean and standard deviation remain the same, and that probability comes out as 0.0013. 1 in 1000 chance. 1 in 1000 chance, okay? Very low probability of getting less than 60. Because the mean is 75, standard deviation is 5. That's why below 60 the probability is very low. Part D. What is the minimum score for the top 10%? Top 10% on the right. That means area in the right tail. Tail is the right portion. 0.1. Area, leftover area is 1 minus 0.1 is 0.9. So you draw a boundary for x. On the right of it is 0.1. On the left of it is 0.9. We have to work always with the area on the left with TI-84. And you are not going to use second verse 2. You are going to use second verse 3, which is in norm. In norm, okay, area to the left is 0.9, mean is 75, standard deviation is 5. Hit enter, and that works out to 81.4. That anybody who scores above 81.4 is in the top 10%. Okay. Then what is the maximum score for the bottom 10%? Bottom 10% means area on the left tail is 0.1. So second verse 3, area is 0.1 and mean and standard deviation remain the same, and that is 68.6. Anybody scoring less than 68.6 is in the bottom 10%. Okay. So remember, always area on the left of the unknown x is what you got to plug in second verse 3 or in norm. Okay. The last part is the middle 50%. Area in the center is 0.5. Okay. Middle 50%. So what is left over in the two tails, one in the left tail, one in the right tail, is 1 minus 0.5. Half is in the center. Area in the two tails is 1 minus 0.5 is 0.5. This is a symmetric probability distribution, normal distribution. Bell-shaped is always symmetric. What does it mean? The left half is equal to the right half. So area in the two tails is 0.5. Area in each tail will be half of that. 0.5 divided by 2 is 0.25. Okay. So we are going to second verse 3 in norm. First we will find the boundary for the left tail. So area is 0.25, mean is 75 and the standard deviation is 5. So we are first finding this boundary for the left tail. So area is 0.25. Okay, and that gives you 71.62. Anybody below 71.62 is in the bottom 25%. How about x1, which is the boundary for the right tail? Here you are not going to plug in 0.25. Here you are going to plug in 0.5, area in the center, plus area in the left tail is 0.25, which is 0.75. That's what you are going to plug in for the area. Mean and the standard deviation remain the same, and that works out to be 78.4. So what does it mean? The middle 50% of the scores are between 71.6 and 78.4. So I'm going to stop here today. If you have any question, just do not hesitate to shoot me a question. I will respond to all of your questions. And if you like this video, please give me thumbs up. That really motivates me, and it motivates me to produce more exciting videos just for you. Okay, so please give me a thumbs up. If you like this video, share with your friends. Okay, and please subscribe to my channel by hitting the red subscribe button on the bottom right corner, and at the same time click on the notify bell button. That will notify you every time I upload a new video, which I do quite often. So please do not forget to check me out tomorrow, and thanks for taking the time to watch my presentation. It really means a lot to me. Thank you very much. Take care. Enjoy the rest of your day. See you tomorrow. Bye.